Okay, namaste and good evening to you all. Uh, Today we have our webinar on evaluation of electric vehicles, which is challenge and opportunity. And we have our speaker today, Dr. Rajesh M. Pinduria. He's a project engineer at Indian Institute of Technology, Mandi. So I would like to welcome Dr. Pinduria from, say, Power Energy Society Nepal Chapter. Like I am the secretary at IEEE PES Nepal Chapter. So I welcome Dr. Pindoria on the behalf of IEEE PES Nepal chapter, as well as the different institutions involved in this webinar today. And I would like also to welcome all the participants to this webinar. Hopefully, this webinar would be fruitful insight to you in the field of electric vehicles. Before moving into the talk itself, I would like to introduce you with Dr. Pindoria. Dr. Rajesh M. Pindoria received a BTech degree in Electrical and Electronics Engineering from Rajasthan Technical University, Kota, Rajasthan, India in 2012, and ME in Power Electronics and Electric Drives from Gujarat Technological University, Ahmedabad, Gujarat, India in 2014. Received a PhD degree in Power Electronics and Electric Drives from Indian Institute of Technology, Mandi, India in 2020. Is currently working as a project engineer at IIT Mandi, India. His present interests and expertise are being inclined towards controlling special electrical motors such as permanent magnet synchronous motors and brushless direct current motors and switched reluctance motor drives for application in electric vehicles and hybrid electric vehicles. He's also working on the design of novel power electronics modulation techniques for the reduction of acoustic noise and vibration of special electric motors. Dr. Pindoria is a founding chairperson of IEEE PLS Site Student Branch Chapter IIT Mandi. Is currently mentor of IEEE Student Branch IIT Mandi. Is a member and an executive and large members of PLS Student Subcommittee and PLS YP respectively. Dr. Pindoria is a member of IEEE, a member of Institution of Electronics and Telecommunication Engineers, a member of Institute of Engineers. So with this basic introduction of Dr. Pindoria, I would like to welcome Dr. Pindoria and hand over the session to Dr. Pindoria.
Yeah. So, yeah, thank you so much, sir.
Here and then let you share your content.
Yeah. So thank you so much, sir, for my brief biodata. So, and once again, I would like to say thank you so much to give me opportunity to present my on the electric vehicle evolution and basic challenges. So just wait so I can share my presentation. So my screen is visible, sir?
Not yet, sir.
Just 1 minute.
Yeah, now it's visible.
Yeah, okay. Just 1 minute. Yeah. Okay. So once again, good evening, all of you, and thank you so much for attending this talk. So there is a IEEE talk, especially on the Power and Energy Society Nepal section. So today's talk, we will see the evolution of electric vehicles, future challenges and opportunity. So before going to start about my presentation, so first I would like to present the outlines. So you can see what is going on for the next 1 hour. So starting with the introduction to electric vehicles and hybrid electric vehicles. After that, schematic layout of electric vehicles and hybrid electric vehicles. Then major components of electric vehicles and hybrid electric vehicles and major challenges of electric vehicles, and finally we can say the tentative solutions of the challenges. So these are the flow of my presentation throughout the 1 hours. Okay, so step by step we can see what is electric vehicle and what is the major challenges. So I can consider the audience maybe the BTech student, maybe the MTech, PhD, as well as a faculty member. So starting of my slides, starting of my presentation, there are two slides. So that is a fundamental concept of electrical drives. So from my point of view, it is important because whenever we go with any advanced level topic, so first we need to understand what is a fundamental behind that. So now we can say the electric drives because now today's topic that is a electric vehicle. So we need to see what is a electric drives. So electric drives. So first we need to understand what is a drives. So system employ for the motion control are called drives. Okay, and then electric drives. So drives employ electric motors are known as a electric drives. So we need to control the motion of any system, then we can say it is a drives. But whenever this system is employed for the electric machine, then we can say that is a electrical drives. Then why it is required? What is the necessary of it? So we can see to control the speed and torque of electric motor. So wherever is electric motor, so basic requirement is we need to control the torque and speed. So ultimately torque and speed both are the mechanical quantity. But as a like electrical engineer, we need to see the electrical parameter. So as a electrical parameter, we can see speed is directly proportional to the voltage and torque is directly proportional to the current. So as an electrical engineer, we need to control only two parameters, that is the speed as well as the current and the voltage. So ultimately we can able to control the electric drives. Okay. So what is the application of the electric drives? So you can see the electric vehicles, ceiling fan, refrigerator, lift, vacuum cleaner, shift. So lot of application nowadays surrounding us from the small level to high level, from the small level to big level application. Everywhere we can use electric drives, other is electric motor. Okay. So we can see like in computer CPU fan, also electric drives. In the domestic application like mixture, we can use the like electric motor. So everywhere we can use from milliwatt to the megawatt rating of the electrical drives. Now slide number 5, that is the most important thing because whenever we can say electrical drives, then first we need to understand major components of electrical drives. So you can see the major components. So that is like power processing unit, electric motor, sensor and controller. So what is the work of these components? So we have the electrical source. So we have universal two types of source, that is AC and DC, alternating current and direct current electrical source. So once we have an electrical source, then we have to give this electrical source to power processing unit. So what is the role of power processing unit? So power processing unit, it is like power semiconductor device to convert one form of the power to another form of power. So we have a AC and DC. Suppose our drives is a DC, then we have to convert AC power into DC power. So power processing unit is a nothing but conversion of the power. So AC into DC, DC into AC, otherwise vice versa. Okay. Then output of this power processing unit, so that is like controllable output voltage, that is the input of our electric motor. So maybe any kind of motor, AC motor, DC motor. So we have nowadays around 20, more than 20 motors in the world. Okay, so depend on the application, we need to choose types of electric motor. Okay, then whenever we can set drives, so ultimately we need to put in the closed loop system. So whenever we put our electric motor in closed loop, then we need to use the sensor to sense the some signal. So some signal means electrical quantity, maybe the mechanical quantity. Electrical quantity, we can say the voltage signal as well as current signal. Whenever we can say the mechanical quantity, so maybe the speed, torque, flux, and everything. So this is a sensor part. Okay. So output of sensor, that is a voltage signal. So every sensor output is a voltage signal. So that is like 5 volt plus or minus 5 volt signal. So that is the input of the controller. So controller may be any type of controller. There is a FPGA controller and DSPA controller, maybe the microcontroller. So FPGA stand on field programmable gate array and DSP stand on digital signal processor. Okay. So depend on the clock frequency, depend on the system requirement, people use the different controllers. But nowadays mostly people use the FPGA and the DSP because of the high clocking frequency and easy to work on this type of controller. So again, second input of this controller, there is a reference signal. So that is maybe the speed, otherwise the torque. Okay, that is a depend on the which type of control signal you use. Okay, so that is a main important thing. And ultimately output of this controller, that is a input of power processing unit. So these four components, there is a power processing unit, electric motor, sensor, and controller. So that is a like major components of electrical drives. And ultimately we connect our motor through transmission shaft with a load. So load may be the electric vehicle, maybe the fluid flow, compressor, refrigerator, etc. So any type of load we can connect with our drive system. So slide number 5, that is a basically introduction of the electric drives. Okay, now starting with the electric vehicles. So we have already IC engine, correct? So why it is required the electric vehicle, and what is the use, and what is the meaning of electric vehicle? So all of you know that is a normal vehicle, otherwise we can say the IC engine based vehicle, which is operate using the oil. So using maybe we can say the petrol, otherwise the diesel, otherwise we can say the natural gas, CNG gas. Okay. So then what is electric vehicle? So in electric vehicles use one or more electric motor or traction motors for the population. So whenever we use electric motor to drive the to run the our vehicle, then we can say that is an electric vehicle. Another terminology that is like hybrid electric vehicle. So hybrid electric vehicle is nothing but it is a combination of two engine. So first one is a IC engine and second one is a electric engine. So by using of this both engine we can drive our vehicle, then we can say this is a hybrid electric vehicle. Now slide number 7 is most important because whenever we propose, otherwise whenever we launch any new application, new device, any new technology, then we need to first understand what are the benefits and what are the disadvantages. Okay, so first we can see the benefits of driving electric vehicles. So what are the major benefits? So first benefit, that is a save money. That is the most important. We can save indirectly money, we cannot save directly money. Indirectly money means initially cost of the electric vehicle is high, but ultimately that is a like starting initial investment cost. So in the time, maybe after the 1 year, maybe the 2 years, you can save up to 70% of the fuel cost. So ultimately you can save whatever you about spend in the IC engine, that amount you save in the electric vehicle. So we can say you can save around like 70% on the fuel cost. And second one is a clean energy. So there is a no pollution. So we can produce like no emission gas. So that is a clean energy. That is a better benefit to the electric vehicle. Reduce the dependency on the foreign oil. So we don't have like oil in maybe the same maybe I don't know in the Nepal that is a oil is available or not, but in India we export the oil from the foreign countries. So that is a reduce the dependency on the foreign oil and have a higher satisfaction level. So higher satisfaction level means so that is a smooth ride. So because there is a no IC engine, only electric motor, so that is a smooth ride. So that's why it is a higher satisfaction level using the by driving the electric vehicle. So these are the four major benefits whenever we drive the electric vehicle. So suppose you have any queries, so please write your question in the chat box. So end of this session we can discuss your question, and I will answer your question. Okay. So now comparison between the electric vehicle and IC engine. So you can see suppose that is a range, we can say the range is a 440 miles for the all the electric, for the all the vehicle, that is IC engine, hybrid electric vehicle, plug-in hybrid electric vehicle, and a 100% battery operated electric vehicle. So suppose range is a fixed, so that is a constant range, then we can easily compare with every vehicle. Okay. So first comparison parameter, that is a refueling time. So how much time it will take to refuel the to charge our vehicle. So whenever we can say the IC engine, so petrol otherwise diesel based engine, so it will take only 5 minutes to refuel the petrol or diesel. Okay. But what about hybrid? Hybrid, it will take around 5 minutes because that is a IC engine plus electric vehicle. That is a battery. So it will maybe the 5 to 10 minutes. But whenever we can say the plug-in hybrid electric vehicle, so it will take around less than 1 hour. And for battery, 100% battery operated, it will take around 4 to 8 hours charging time. So now what about the efficiency? So you can see the whenever we can say uh, uh, IC engine based vehicle, so that is a not efficient because that efficiency may be the very less. Also, it will produce the CO2 gas. Okay, but hybrid electric vehicle is efficient compared to the IC engine vehicle. Okay, and hybrid electric vehicle, so that is a not that is a more efficient compared to the IC engine. And electric vehicle, that is a 100% battery operated electric vehicle, that is the most efficient efficiency because that is a run on 100% electric power supply. Okay, so these are the typical comparison between the conventional and the electric vehicles. Now slide number 9, it is a configuration of the electric vehicle. So suppose somebody want to design, otherwise somebody want to do the research on the electric vehicles. So first we need to identify what are the major component and what is the configuration, typical configuration of the electric vehicle. So I made this configuration in the 3 parts. So first one is the electric propulsion subsystem. Second one is the energy source subsystem, and third one is the auxiliary subsystem. So starting with the first system, that is like electric propulsion subsystem. So as a driver, so driver have a controller. So that is we can say accelerator and brake. So these two are the controller parameters. So suppose you want to drive the fast, then you have to push the more accelerator. You have to give the more accelerator. Suppose you want to stop, then you need to give the brake. Okay, so these are the common thing, accelerator and brake. So that is our input so from the driver side. Then ultimately electrical propulsion subsystem, then major part we can say electronics controller, power converter, electric motor, and mechanical transmission shaft. So we need to transmit the power to transmission shaft, and ultimately wheel. Okay, so these are the major components whenever we can say electric propulsion subsystem. Now, what about the energy source subsystem? So that is like energy management system. That is the most important thing. We have to manage the energy when we design the electric vehicle. Energy sources, which type of energy source is available? Maybe the renewable energy, maybe the thermal energy. So there is a type of the energy system. Energy refueling unit. So we have to maintain the refueling unit so we can easily charge our electric vehicle. And last subsystem, that is like auxiliary subsystem. So we can say the auxiliary power supply, power steering unit, and the temperature control. So we need to maintain the temperature. So maybe there is a no any hazardous operation nowadays. Maybe you heard so around like 10 electric vehicle is blast, around 5 electric vehicle blast in the per day. Why? Because of the not electrical safety, because of the high temperature rise in the electric battery. So we need to maintain the temperature below the saturation limit. Okay. So that's why it is a temperature control unit. So nowadays people working on the condition monitoring of the electric drive. So that is the most important research topic nowadays. So these are the overall configuration of the electric vehicles. Now schematic layout of the electric vehicles and hybrid electric vehicle. So we can start from the right hand side of the slide number 10. So there is a software part. We can say the DTC, there is a direct torque control. otherwise that field oriented control. So any type of control algorithm you can use to control the your drives, control the ultimately electric motors. So hardware we can use FPGA, otherwise DSP, otherwise microcontroller. And then is a two-way communication between the energy storage system, that is ultimately battery, otherwise ultra capacitor. So nowadays people also working on the ultra capacitor in instead of the battery. Then power processing unit, so that is a power electronic circuit, and ultimately motor, otherwise the generator. So we can say motoring mode operation as well as the generating mode operation. So we can say regenerative mode of operation. And ultimately transmission shaft. So that is a mechanical transmission shaft which is connect with the front wheel and back wheel of our electric vehicle. So this part is we can say the electric vehicle. And hybrid electric vehicle, then we need to add the IC engine, then we can say that is a hybrid electric vehicle. Okay, so these are the schematic layout of the schematic layout of electric vehicle as well as the hybrid electric vehicle. Now you can see this is a pictorial view of the our electric vehicle. So as I said, so major components is electric motor, otherwise generator. So that is a working in both. So suppose this motor is running, then it's a motoring mode, and suppose we give the brake, then we can produce again energy. Then we can say it is a regenerating braking operation. AC to DC converter, DC to DC converter, inverter, battery junction, and ultimately battery. So these are the typical pictorial view of the electric vehicle, and these are the really major components for the electric vehicles. Now, most important thing, that is like major challenges. So today's our topic, that is like major challenges and the major problems. So I divided this major problem into four parts. So first one is a technical, second one is a infrastructure, third one is a policy, and fourth one is a market. So these are the four major components, that is the four major challenges what we are really facing. So in the technical, what is a technical major challenge? So we can say the efficiency of battery, how we can increase the efficiency of battery. Driving range of electric vehicle, suppose you want to drive maybe the like 100 kilometer, okay, with one charging. So that is a not possible with the like normal electric vehicle. So we need to work out on the like high range of the battery. Okay, so that is a driving range of electric vehicle. Charging time, so nowadays customer want like less charging, less stop for the charging of the electric vehicle. So we need to work out on the charging time. So how we can improve the charging time. Safety, environmental impact. So these five are the major technical problem in the electric vehicle. Now in the infrastructure wise, so charging infrastructure. So we need to develop the charging infrastructure to charge our electric vehicle, and that infrastructure, it is a not for the particular any one design of electric vehicle. So that is a common for the every electric vehicle. Okay. So suppose Ola is designed like electric vehicle, maybe any other company Ether is designed the electric vehicle. So it is a not like particular this Ola company, Ola based vehicle is charged for particular this XYZ charging station. It is not like that. So we need to design the charging station that is a common charging station. And smart grid operation. So smart grid operation is nothing but that is like two-way communication. So power grid to customer. So that is a communication between the customer to power grid. Then we can say that is a like smart grid operation. Okay. Then battery recycling and dedicated lanes for the electric vehicles. I don't know that is a possible, yeah, no, but again that is a infrastructure challenges. So is it possible to dedicated lanes for the electric vehicle? Then policy. So government need to design the taxable policy for the electric vehicle. And second one is a subsidy on the fossil fuels, electricity tariff policy. So basically this policy is for the major part is a government side. So government have to design the policy. So that's why people want to people will buy more and more electric vehicle. So we can replace the IC engine with electric vehicle. And finally marketing. So testing and certification. So once the more electric vehicle is designed, then we need to test and satisfy. So certification. So this is a very good, and now you can sell your electric vehicle to customer. Vehicle servicing, so we need to provide the like fully service. Suppose once the motor is, suppose once the electric vehicle is damaged, so we need to give the proper service. Okay. High capital cost and financing. So nowadays, initially capital cost is a very high, but we need to give the government will give the subsidy. So ultimately, it will reduce the price of the our electric vehicle. Electricity quality, market for electricity storage, consumer perception, because suppose like normal people, they don't buy the electric vehicle. Why? Because it's a high price. Maybe the normally 30 to 40,000 is a high price. So why then why should normally people buy this electric vehicle, and why should people pay the high amount to buy the electric vehicle? So we need to give the more awareness on the electric vehicle. So that's why like consumer perception. So we need to change the like consumer perception. Okay. Raw materials for the battery. So these are the major challenges for the electric vehicle. So there is a technical, market, policy, and infrastructure. Now types of the battery. Okay. So these are the again we have like lot of types of battery. So that is we can say the battery electric vehicles, hybrid electric vehicles, plug-in hybrid electric vehicles, fuel cell electric vehicles. So I'm not going in detail what are the different topology and what are the operation due to the time limitation. So I can just give the brief about the battery operated electric vehicles for major components. So that is like battery, inverter, electric machine, and single speed gear system, and basically driving wheel. So this is like we can say the typical structure of the battery operated electric vehicle. Now comparison of the different types of electric vehicle. So you can see major comparison factor, that is like features and problem. Whenever we can say battery operated electric vehicle, then we can say features is no emission, not dependent on oil, but problems with battery price, capacity, range, charging time, availability of charging station, and high price. So these are the major problem in battery operated electric vehicle. And what about hybrid electric vehicle? So there is a management of energy source, battery and engine size optimization. These are the major problems whenever we can say the hybrid electric vehicle. Fuel cell electric vehicle, that is basically we can say hydrogen fuel cell electric vehicle. So that is like problem is cost of the fuel cell, feasible way to produce the fuel, and availability of the fueling capacity. So these are the major problems which currently we are facing in the electric vehicle. So we can say the different type of electric vehicles. Now common battery use in electric vehicles. So nowadays these are the 5 common battery which are used in the electric vehicle. But again people are working on the ultra capacitor, super capacitor to replace the like battery. So common battery is a lead acid, nickel metal hybrid, and then is a lithium ion, nickel zinc, nickel cadmium. So these are the 5 types of battery which are currently used in the electric vehicles. Now electric motors for the electric and hybrid electric vehicles. So heart of electric vehicle, that is a electric motor. So without electric motor we cannot design the electric vehicle. So that is a heart of electric vehicle. So normally people use induction motor, PMSM, so basically permanent magnet motor, maybe the PMSM, yeah, PLC motor, and switch reluctance motor, that's a SRM motor. So stator of the all the motor, that is the same stator. So that is a 3-phase winding on the stator. But major difference, that is the design of the rotor. So you can see the rotor of the induction motor, there is a aluminum sheet or bar, and rotor of the PMSM and BLC motor, that is like permanent magnet, and rotor of the SRM, there is a pieces of laminated steel. Okay, so these are the major advantage in the different motor. So current research on the SRM motor. So is it possible to we can produce the high torque, and size of the motor is very small size. So nowadays people working on the SRM motor to use in the electric vehicle. So slide number 18, that's a like typical torque speed characteristic of the different motor. That is an induction motor, PMS induction motor, PMSM motor, as well as the SRM motor. So I am not going to detail, but suppose somebody want to design the electric motor and choose the any electric motor, then we have to first study on the characteristic of the electric motor. Then we need to say, then we can say this motor is very good for this particular electric vehicle. Okay. Now this slide number 19, there is a particular comparison of the electric motor. So I'm not spending too much time on this comparison table, but this is for your kind information. So you can see the brush DC motor. So few company use initially for the electric vehicle, but now people move on the BLDC motor and PMSM motor. So in the year of 2005, Toyota used the BLDC motor, but nowadays people use the PMSM motor, not the BLDC motor. BLDC motor used in the two-wheeler as well as the three-wheeler, but in the four-wheeler, mostly people use the PMSM and induction motor. So PMSM is for use Toyota, Nissan, Soul electric vehicle. And induction motor recently used the Tesla Model S, Tesla Model X, Toyota, and most of the company use the induction motor. But that is a depend on the efficiency and depend on which type of electric vehicle. Maybe that is a racing car, yeah, something different. So that is a depend on the load characteristic and SRM motor. So recently work out on the SRM motor because of the very easy to operate and very design is very simple. So that's why people use the SRM motor, but issue with the torque ripple and current ripple. So there is a acoustic noise issue and vibration. So these are the coordination operation of electric vehicle. So there is starting, low speed running, acceleration, high speed running, and the braking operation. So these are the 5 coordination of the operation of electric vehicle. So where we can operate like electric vehicle in hybrid mode, and which condition we can operate motor is a 100% electric vehicle. So these are the typical scenario for the operation of the electric vehicle. But this is a not, we can say, thumb and rule. Suppose you increase the efficiency of our electric motor, then IC engine is not required. Okay, so that is a depend on the like operation of electric vehicle and which type of motor you use and what is the power rating. Okay, but this is basically for the like basic understanding of the mode of operation of our electric vehicle. So slide number 21, that is like typical placement of different type of power electronics converter. So as I said, power processing unit is the heart of the electric machine, correct? And electric machine is the heart of the electric vehicle. So ultimately we need to work out on the power processing unit, that is nothing but power electronics converter. So you can operate this power electronics converter, that is an inverting mode as well as non-inverting mode. So we can say rectifying mode as well as the inverter mode. So whenever we can say inverter mode, that is means our drives is operating the regenerative braking. Okay, so we need to feed our power energy to the grid again. Okay, so we can say our charging of the electric battery. So that is like regenerative braking. Now, effects of electric vehicle. Whenever we can say any application, so any application is not 100% correct. So some of the disadvantages is there, some of the advantages is there. Okay, so now we can say, suppose we replace the 100% of IC engine with electric vehicle, then what is the impact of electric vehicle? So impact on the power grid, that is a major issue. Impact on the environment and impact on the economy. So first we can see the impact on the power grid. So that is like negative impact as well as positive impact. So first let's see, we can see the positive impact. So positive impact, that is a facilitate with a smart grid. So somebody maybe the power system area, so they know better on the facilitate of the smart grid. So that is a most important thing, and there is a better technology to connect our power grid with the smart grid. Okay. Then vehicle to grid operation and grid to vehicle operation, that is also possible, and integration of the renewable energy system. otherwise we can say renewable energy sources. So we can easily integrate our renewable energy system with a electric vehicle power supply. So these are the positive impact. But what about the negative impact? So that is a like voltage instability. So suddenly you charge your electric vehicle and suddenly you put your plug in the power supply. So voltage is unstable. So that is like voltage instability. Increase the peak demand. Suppose at a time 100 vehicle is charging, then what happen with the voltage? So suddenly increase the load demand. So that is again issue. Harmonics, voltage sake, and power losses. So these are the negative impact on the power grid. What about the impact on the environment? So that is a less greenhouse gases emission. So that is again we can say there is a positive impact on the by impact of electric vehicle. Impacts on the economics. So lower operating cost and the chance to benefit from vehicle to grid and grid to vehicle operation. So these are the typical impacts of electric vehicles. Now limitation. So I divided limitation in the three parts: social problems, technical, technological problems, and economics problem. So social problem means social acceptance. As I said, so starting cost is very high. So normally people will not buy, but educated people maybe understand the situation of the environment and everything. But normal maybe the like lower class family maybe not able to spend the too much amount on the buying the electric vehicle. So that's why it's a social acceptance. Insufficient charging station. That is like social problems. And what about the technological problem? That is a limited range, long charging period, and safety problem. And what about the economic problem? That is a high price. So nowadays we need to work out on these three problems: that is social problem, technological problem, and the economics problem. So suppose we have these three problems. So what is a tentative solution of the current limitation of electric vehicle? So that is a tentative solution. We can say suppose limitation is limited range. Then what we can do for this limited range? So probable solution is better energy source and energy management technology. So we need to work out on the better energy source as well as energy management technology. So nowadays very hot research topic that is like battery management system. Okay, so suppose somebody is doing PhD, otherwise maybe the professor. Suppose somebody want to write the project proposal, then battery management system is a very good topic. That is a hot topic nowadays. That is a, like in electric vehicle. Long charging period, so better charging technology. So nowadays people going with ultra capacitor, super capacitor for the better charging technology and also for the battery operation. Okay. Safety problem, advanced manufacturing scheme and to build the quality. So by design the advanced manufacturing, so we can resolve the safety issue. Insufficient charging station, placement of sufficient station capable of providing the service to all kinds of vehicles. So as I said in the beginning, so it is a not like any one vehicle is charging only one particular power charging station. Anywhere you can go and charge your vehicle, XYZ vehicle you have. Okay. Then high price. So mass production, advanced technology, and government initiative. So by using this combination by mass production, advanced technology, and government initiative, we can reduce the price of the electric vehicle. So these are the tentative solution of the current limitation of electric vehicle. Now, what are the footrace? So that is the most important. So what are the footrace of the electric vehicle? Sorry. So major footrace, that is a factor we can say recharging. So how much time it will take to charge our electric vehicle? So we can say footrace is weight of the charger. Ultimately, we need to reduce the weight of the charger, durability, cost, recycling, size, and charging time. So these are the footrace factor whenever we can say the recharging of the our battery. Hybrid electric vehicle, so there is a battery, durability, weight, and cost. So these are the like footrace for the hybrid electric vehicle. And hydrogen fuel cell, so that is a cost, hydrogen production, how much hydrogen we can produce, so it is sufficient to run our electric vehicle. Infrastructure, storage, how much hydrogen we can store and how we can store, and durability and reliability. So these are the major footrace whenever we can say the hydrogen fuel cell electric vehicle. Auxiliary power unit, so size of overall size of our electric vehicle, cost, weight, durability, safety, reliability, cooling system, and efficiency. So we need to give the proper cooling system to maintain the overall temperature in the below the like saturation limit. So we need to provide the proper cooling system, increase the efficiency overall. Then we can say our electric vehicle is working very well. Okay. So these are the basic footrace in the key electric vehicle factors. Okay. Now, major trends and future developments. So you can see slide number 26 from the bottom of the pyramid. So we can say the overhead power supply, wireless power transfer, better battery technology, better charging technologies, and vehicle to grid and grid to vehicle operations. So these are the future development plan. So nowadays people working on the wireless power transfer, but in India and maybe I hope in Nepal, wireless power transfer for the electric vehicle maybe now in starting stage. But in the USA and Japan already implemented wireless power transfer technology. So current, finally, maybe this is my last slide. So current area of the research. So that is a reduce the mass, ultimately reduce the mass of our electric vehicle, decrease material and manufacturing cost, improving hardware as well as the software, battery alternative to maximize the nickel metal hybrid that is currently used. So we need to working on the reduce mass, decrease material, improving the hardware as well as software part, and the battery operation. So these are the current area of the research. Okay. So traction motor. So suppose somebody is working on the motor design. So that is like traction motor. So that is electromagnetic, thermal, mechanical, NVH testing. So you need to work out on this type of parameters. Suppose you are a designer of the traction motor. Okay, so you have to work on the thermal analysis, noise and vibration, testing, mechanical structure, everything you need to consider. Suppose you are a designer of the electric motor. Electric vehicle chargers. So suppose you are a design of the electric vehicle chargers, then you need to work out on the power electronics system, hardware design, embedded coding, testing hardware as well as software, software in the loop, machine in the loop, and the hardware in the loop. So you need to work out on this factor. Suppose you are your role is a like electric vehicle chargers. Okay. Traction battery. Whenever you use the battery, then we need to work out on the PEG simulation, cell simulation, PEG thermal analysis, and electrochemistry. So which type of chemical is used to design of the traction battery? So these are the major factors whenever we design the battery for the electric vehicle. So finally, conclusion of the today's presentation, that is we discuss about the electric drives and its application. So what are the major components of electric drives and its application? Finally, major components of electric vehicles and hybrid electric vehicles, various type of electric drives and power electronics converter topologies, challenges of electric vehicles and hybrid electric vehicles, current area of the research of electric vehicles, and tentative solution of the problem. So we cover like following things. So this is a 1 hour discussion. We like overview of electric vehicle evolution and the basic problem statement and tentative solution we discuss in the 1 hour presentation. So these are the reference which I used to prepare this presentation. And finally, I can say thank you for your kind attention. So I can say the future is really in our hands. Suppose you want to make your future is bright, and suppose you want to really take care of our children, then we need to think nowadays on the greenhouse emission gates. Okay. So it is a ultimately we can say our future is in our hands. So that is up to you. You want to make your bright future. We need to think our child everything. Okay. So thank you so much. If you have any query, if you have any question, so please let me know so we can discuss on your query and I would happy to answer your question. Once again, thank you so much.
Uh, Thank you, Dr. Pindoria, for an insightful speech on evaluation of EV, future challenges and opportunities. Now we have entered the Q&A session. We'll address some of the queries in the chat box, given the time constraints. So, so Dr. Pindoria, shall we start with the Q&A session?
Yes, yes, yes.
Okay. So the first question is by Nitish Biswakarma. So he's asking, what about the manufacturing cost? I guess, having said that, he's talking about hybrid EV, PHEV, the technologies you have mentioned, and on small as well as on large scale. That is what he's asking, about the manufacturing cost of different type of EVs on small scale and large scale. When you write the question, please write it clearly. So,
Yeah. So nice question. So whenever we can say the cost of the electric vehicle, yeah, hybrid electric vehicle, then we need to think on the which type of electric vehicle. That is like two-wheeler, yeah, electric bicycle, yeah, three-wheeler vehicle. So now I consider the like we can say the like electric bicycle. So cost of electric bicycle is around range of the 35 to 50,000 rupees. That is a depend on the size of the electric bicycle and which company is designed. So range maybe 35 to 50,000. But whenever we can say the like bike, okay, then we can say that bike of the cost of the electric vehicle bike, it is vary from 1 lakh to 1,20,000 Indian rupees. Okay. Whenever we can say there is a three-wheeler vehicle, we can say the like e-rickshaw, that is a cost is very 3.5 lakhs to 4 lakh Indian rupees. Whenever we can say the racing, not racing car, that is like car, four-wheeler car. So maybe that is a cost of this car, it is maybe the 15 lakhs to the 20 lakhs rupees. So whenever we can say the large vehicle, that is like buses, public bus, public service bus, that is like crore rupees. So in the 1 crore INR. So these are the typical range of the manufacturing cost of the electric vehicle. I hope Nitesh, I answer your question. Yeah.
okay. The second question is by Madhav Sapkota. So he's asking, uh, I have found that though there is advancement in light system, but still electric vehicle not implementing LED lights. Why? That is what he's asking. And
Yeah.
another question also, that out of four various type of EVs, which is suitable as for our country? I think it will be hard to tell you about Nepal, but he's asking, maybe we are similar in terms with India, so that's why he's
Yes.
asking geographical and economic system. So our economic system is different. Yeah.
Yeah. So first question is a very interesting question. There is a LED light. So I really surprised. So Madhav is really focus on the LED light because there is a nowadays people not use the LED light. So you are correct, Madhav. Yes, people not use the LED light because recently in the last year, one in the IEEE magazine, one the research work did on the LED light. So there is a like lot of disadvantage on the LED light. So that's why people are not used on the LED lights for the electric vehicles. So in the I currently I'm not remaining the year month of the magazine of the IEEE Power Energy Society magazine. So cover the one research topic on the LED light. Okay, so that's why people not use the LED light on the electric vehicle. Now come to the second part. Out of the four various type of electric vehicle which is suitable as per the country geographies and economic system. So, Madhav, honestly, I can say this is a depend on the like geographic and economic system. But currently, I don't have a sufficient knowledge which type of electric vehicle is suitable. Depend on the country. But nowadays, current situation, people are working on the all type of electric vehicle, battery operated electric vehicle, hydrogen electric vehicle, and the hybrid electric vehicle, because electric vehicle is not like full and face technology, correct? So nowadays people working on this type of technology and slowly improve the performance. Then we come on the geographical and economical issue to consider the which type of electric vehicle is suitable for this particular region, for this particular country, correct? Yeah.
Okay, so next question is by Damodar Dahal. I think he is referring to some of your slide when you mentioned catching fire. So he's asking what is the reason for catching fire. And he has another question, but I could not quite get his question. Maybe there is a typo. So which one is better among conversion or electrical vehicle? Damodar Dahal, can you please, write it if you can? And in the meantime, Dr. Pindoria will address your first question, like the reasons for catching fire.
Yeah. So catching fire, one of the most important reason that is like temperature increase. So major part in the electric vehicle, that is like electric motor, power processing unit, that's the like power electronics components, and major hazards component, there is a battery. So whenever we use the electric battery, then ultimately increase the temperature continue. So you can see the simple example that is like mobile. We nowadays we use the like smartphone. So suppose you continue operate our smartphone, then it will heat up, correct? So why it will heat up? Because of the battery, because batteries continue consume the power. So battery is nothing but chemical, so that's why it's a continue increase the temperature. Suppose temperature is continue increasing, so after the saturation limit of this battery, it is a fire, correct? So that's why because of this battery it will fire. Okay, so that is a one of the most important reason for the catching the fire. Okay, second one is
Uh,
a which
so
one.
next one, like yeah, he wrote it again. So which
uh,
one is better for use, like conversion of combustion engine into electric vehicle or pure vehicle? That was his another question.
yeah, so of course electric vehicle is better, but as a we can say the initially cost is very high. But from my point of view, suppose we replace the 100% of electric vehicle by IC. Suppose we replace the 100% IC engine by electric vehicle, then what we can do with the IC engine? Suppose we dump IC engine in the land, then what about again the pollution? So parallelly, we need to work out. Suppose we replace the 100% of IC engine with electric vehicle, then what we can do with this IC engine material? Okay, that is the most important thing. And nowadays, as per the my knowledge, we cannot convert our nowadays there is a not more technology on the conversion of the IC engine to electric vehicle. So nowadays people working on the totally 100% on the electric vehicle, better to compared to the like hybrid electric vehicle. So that is the most important thing. But I can say electric vehicle is a good compared to the conventional conventional vehicle, that is like IC based IC based vehicle. Okay. So ultimately electric vehicle is very good.
Okay, so the next question is by In Rai. Okay, I also actually wanted to ask this question. So, will the ultra capacitor be complete replacement to battery, or it will be just enhancing the lifespan or efficiency of battery? I will add on this question that battery and ultra cap have separate properties in terms of energy and power density. So I think hybridization of battery with ultra cap or other components might be the solution. And ultra cap is again expensive, very expensive. So yeah, can you please? Yeah.
Yeah. So you are correct, sir. So ultra capacitor and super capacitor as well as the battery, we have three components. So totally characteristics different, property is also different, charging times also different, everything is a difference. But nowadays people working on the ultra capacitor and super capacitor because we can charge very fast of this capacitor, and size of this ultra capacitor and super capacitor compared to electric batteries reduces. Okay, that's why people going on the ultra capacitor and super capacitor. But I don't have sufficient knowledge on this characteristic of the super capacitor and ultra capacitor. Is it really enhancing the life of the electric vehicle? Yeah, no. So currently, I don't have a sufficient knowledge on this technology, that is like ultra capacitor and super capacitor. But whatever I have, so I can say these are the all are the different property and different characteristic. So maybe it will helpful to replace the battery with a ultra capacitor and super capacitor. But I am not sure because these are the not my current area of the research. But I can say maybe this is the helpful for the replacing of the electric battery.
Yeah, I think maybe they will use ultra cap ultimately to reduce the charge discharge cycle of batteries during transients, and then
Yes.
that will increase the lifetime of the battery. So thank you. Having said that, thank you, Dr. Rajesh Pindoria. That was our last question. If we have any further question, we can address it. If you have, please type it fast, or uh, let's wait for 30 seconds.
Yeah. If you
Yeah.
have any question, then you can also mail me. So you have my email ID. So also we can discuss.
Yeah, okay. So, thank you, Dr. Rajesh Pindoria, and all the participants for making this session engaging. So, now I would like to request Dr. Shailendra Kumar Jha, Secretary of IEEE PES chapter, Nepal chapter, to provide his closing remarks and vote of thanks. Thank you.
Thank you, Susan. So, thank you, Dr. Pindoria, for your nice talk on this electric vehicle and its issues forward.
Most welcome, sir. I hope you really enjoy the session.
Yeah, it was really nice, but yeah, we'd like to work together further in this area, and particularly all the participants, whether they were students, researchers, faculty members, or engineers from different institutions or organizations. Probably they would love to work with you in further collaboration with IIT Mandi and you itself. So it will be nice. Like we'll be collaborating with you further in the research works, uh, not only electric vehicles, further other works even. With this,
Sure.
I would like to thank you for your valuable time, providing us an opportunity to put you as a speaker for this webinar today. And I would
Sure.
also like to thank all the participants, students from different institutions in Nepal, uh, engineers and researchers from different organizations in Nepal to be a part of this webinar today. I'd like to ask you all to contact Dr. Pindoria or our IEEE PES Nepal chapter team so that we can link you with Dr. Pindoria and his research work further. And with this, we have a small certification of appreciation to Dr. Pindoria, signed by our uh, chairperson, Dr. Navraj Karki. So
Yeah.
he was not able to attend because he is in India, in Delhi, probably for some work. So this is a certification appreciation from IEEE PES Nepal chapter to Dr. Pindoria.
Thank you so much. Thank
So
you.
to
It was,
request Dr. Pindoria to accept this online itself,
yeah.
and I'll
Thank you so
provide
much.
you
It is very
the
nice.
PDF copy.
Yes. Thank you so much. Yeah.
So thank you, sir, for your nice talk today, and thank you all to be at the part of this session today. We'd like to inform you that we'll have another webinar coming up soon in the next month, and then we'll have a conference by IEEE PS Nepal chapter in August itself. So I'd like to request you all to be the part of the further webinar and the conference in August 2022 itself.
Yeah.
So thank you all. Thank you, Dr. Pindoria. Thank you all the participants and panelists today.
Yeah.
Thank you all. With this, I would like to end the session.
Yeah.
Okay, thank you, thanks,
Thank you so much. Thank you. Yeah.
thank you.
Thank you so much.
Namaste and
Namaste.
good
Namaste. Yeah. Thank you.